Hi, I'm Moshik Rubin from Cadence Verification IP team. Thank you for joining this short demo of Indago Protocol Debug App. Indago Protocol Debug App is a GUI-based tool that makes debugging of protocols and memories easy, intuitive, and productive. Before moving to the demo itself, let's review the flow and understand how it works. The VIP runs against the DUT, device under test, in simulation on top of one of the different simulators. All the data traffic, state machine transition, and any relevant information is recorded by the VAP into a dedicated database. Once the simulation is done, the protocol debug app GUI reads from the database, analyzes the data, and presents it in protocol meaningful way, enabling to go back and forth in simulation time and find the root cause of the problem. The demo today covers a simple and common AXI to DDR4 bridge as illustrated in this diagram. Now, let's go directly to the demo and review the different app modules. The protocol debug app has several main modules: the smart log, the live story, channel viewer, state machine viewer, the hierarchy pane, and the memories. The hierarchy pane contains all the instances of the VAP in your test bench and enables to see the current value of each field and object. In our demo, we can see DDR4 device and several AXI master and slave. If we go through the DDR device, we can see valuable information, for example, about the configuration register and the value for each time of the simulation. We can also search for specific parameters. Let's look for banks, for example, and here are the relevant parameters for DDR4 banks. We can also look at the callback that occurred during the simulation and see how many times each one of them occur. We can see a very similar picture for any VAP, like here for the AXI master. The hierarchy pane also gives indication if there was an error or warning in a given instance during the simulation. Error marked in red and warning in yellow. Clicking on one of these error marks would take us into the specific error or warning message that came from the VAP, which brings us into the second module, the smart log. The smart log contains all the messages that were captured during the simulation and enables easy and advanced filtering. For example, we can look for messages that contain the word read and add on top of it all the messages that contain bank 1. We can also limit the simulation time and later on save the query for future usage or share it with colleagues. Next is the channel viewer. The channel viewer is one of the most valuable modules of the app, providing visualization of the protocol traffic in a similar way to the lab equipment view. Let's enlarge the channel viewer window and go to the hierarchy pane. Here I can choose from which instance I want to see the traffic for. I'm clicking on the channel viewer icon for the DDR4 module, and now I can see the specific traffic channels for DDR4. I can click down the command and see all the different commands that were sent during the simulation. If I click on one of the specific items, I can see the fields that compose this packet. I can also click on the command packet and ask to highlight the linked content. Now I can see the specific data related for this read command. Similarly, I can choose the AXI traffic and see the channel viewer for the AXI. Now, the channels are according to the AXI protocol, and I can go and see specifically the AXI burst, pick several packets and see them side by side so I can easily compare them. The next module is the state machine viewer. Debugging state machine can be very challenging, especially in complex protocols. This module takes the state machine diagram as it appears in the spec and brings it to life according to the simulation. Let's look at the DDR4 state machine viewer. We can enlarge it and click the errors skip between state to state, see the transition time, and the next and previous state. The grayed out states are those that were not visited during this particular simulation. The memory viewer provides simple and intuitive way to track memory spaces. I go again to the hierarchy pane and click the memory icon of the DDR4 device. Now I can see the memory map of this particular DDR4 device, and I can see each value for all the addresses in any simulation time. Clicking on one of the addresses, you can see the previous value of this address or the next one. We can also send it to the live story viewer, which takes us to the last module of today's demo. The live story module shows how a specific object has changed during the simulation. In this case, we see how a specific address was changed during the simulation and which values have been assigned to it. But the same model can be used for a specific transaction to see how it was changed during the simulation, or even a state machine. With that, we conclude this short demo of Indago protocol debug app for DDR4 and AXI. Thank you for your time.